yesterday the matplotlib. Now what is Seaborn? So Seaborn is an open source Python library which gives you a very high level visualization method for visualizing your data, what you write, what you present. Okay. So okay. So we use Seaborn for this stuff, right? So this is you can say a higher version of a matplotlib. You can say this as a higher version of the matplotlib. Okay, fine. So like whatever we will be making, like tomorrow we will be making up the models. That will be the last session date tomorrow. Okay, so we'll be making some machine learning models and be looking up to the things over there. So Seaborn, if I just summarize this, it will be said as that Seaborn in matplotlib you try to plot up your data, whatever you write. Like now here in the Seaborn, it tries to make that plottings even easier, right? You can do some bit complex plottings, you can say. Okay, so every complex plottings can be done in very easy manner. Okay, and Seaborn has a lot of feature. This library, you can go with the built-in several methods. You can go for defining or visualizing some unvariate data or bivariate data. Now, what is unvariate and bivariate? Like if you are working with one particular data, that is an unvariate data, and when you are working with two data, so more than one data, that is called as a bivariate data. Okay, and you can go in fitting and visualizing like regression models we'll be doing tomorrow, and you can just go for statistics plotting and a lot of things, numpy, pandas, and data structures. Okay, so we'll start it with the C1. Okay, now what are the dependencies and what are the data sets and what are the libraries needed up there. Okay, so in Cborn, whenever you come, right, what I said that you first have to import Cborn as SNS. So you have to import all the dependencies, right? So I'll be importing pandas, I'll be importing numpy, I'll be importing matplotlib. So these are the all dependencies of this Cborn, right? So for managing the data sets, I am importing pandas, okay? And for additional customization, I have imported matplotlib. And what is this numpy for? For doing some calculations, okay? Right? All right. Now, what are the data sets? How to load data sets from the Cborn? That I have said you that whenever you want to load any data set from a Cborn, you write load data set and then you write up the things. So this is for like for loading data sets from Cborn, we use this command, right? Load data set, and that is like load. Okay, so we use this for loading any data set. That's load underscore of data set and write the data set name, right? There you write the dataset name without the file extension. Okay, now, so well, how many datasets are there to use, right? How many datasets are there to you can say how many datasets are given inside the built-in method of the Cborn. So to see all the datasets that are easy to use, free to use, we'll be looking on that print. That what we want to see. We want to find all the datasets that is there in the Cborn. So that is just SNS dot get all the dataset names. So that is get the dataset names. That's it. I'll run this, and it will print all the dataset names we are having. So it is having anagrams, it is having enscom, attentions, brain networks, car crashes, diamonds, and what is there? Dots, exercise, flights, okay, ephemery, and then gammas, then geysers, IOS, and a lot are there. Okay, so these are the datasets you could use, or you could directly load it from here. Okay, right. So let's just come with one of the dataset, and we'll see. Right. So for loading any dataset, let's say we are loading a dataset DF named as DF, and it's like SNS dot load underscore of dataset, and then we write up the things. So let's say we are loading this tips. Okay, so I'm loading tips, and I will say I'm gonna print df dot head. So this is total bill, tip, D6, the smoker, the day, the time, and the size. This data set just tells you about just a hotel kind of thing, right? A tip for. So total bill of a person 16.99, given tip as 1.01, was female, was not a smoker, came on the Sunday and had dinner time, and the size were 2, right? That is 2 people. Okay, right? So who paid the bill and what paid the tip and like that. Okay. Now this is for the tips, right? So how many data sets are there? You have seen. Now similar to this, there are various styles, guys. There are various styles in the Seaborn to use to for printing up, showing up your data in front of anyone. So how many styles are there? How we see the styles? Okay. So what are the styles we are having in this Seaborn, right? So that is called as figure styles. Okay. So that is particularly called as Seaborn figure styles. So how many figure styles are there? Or if you want to set any figure style name, what should you write? Okay. So how many styles are there? Figure styles are follows as dark grid, white grid, simple dark, white, and ticks. Okay, these are the styles. And you write SNS dot set any style name. When you want to set any style, you just write SNS dot style name, and that's it. How you make this one. Okay, I'm making this as a comment. Or you write style name. You write the styles. Okay, that's it. So these are the styles we are having in the Seaborn, right? So let's just see one kind of plotting this. So I have imported the numpy. So what I do, let's say this is my A, and this is going to be, let's say, from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is going to be B, which will be np dot the sign of this A. And just plotting of the things. So plt dot plot. So I'm plotting A and B respectively, right? And you can see the plottings as well. Okay, and the same plotting, if I say that I want to set the style, and I say it to be white grid. So in the dark grid, I could see up the things, right? Got it, my points. Okay. So there is similar to this. There are several access style. Several access style are there. So if you just write Okay, fine. So let's say if we write for the x's, we'll be getting it for the x's styles. Okay. Why it is not working style? I think it was for the style. Yeah. Okay. So is it for that too? Hmm. Okay. So these are all the styles of the XS, right? You want grid, XS dot grid true. Yesterday we did this, right? If you remember, I think Tarang was yesterday, so he might have focused on this. The XS dot grid we wrote true. And similar things, there are various such operations you can do on the XS styles, right? So when you want to set any XS style, right? So you can set those things, right? And similar to this, there are several color palettes. There are several color palettes. These are just for the formattings, right? If you see, these are just called as figure SSL. Okay, so these are used just for formatting up your visualization, right? So we have color palettes. You say color palette, right? So what is a color palette, right? So colors, this plays a very important role when you plot any data. Colors plays a very important role in several aspects, right? So this function color palette can be used to give colors to the plots. Okay, so you have parameters that is n colors, desat, palette. There, so desat is the proportional to desaturate each color, and the n colors is like the number of colors by default is the 6. Okay, so we'll see up right how we write up the things. Okay, so in the color palette, so in the color palette we'll write sns dot the color palette, and then I'm going to write that palette is equals to now none. Okay, so no palette I'm writing. Number of colors, let's say 6, or for now let's say this none. I'm giving you the parameters there are, and desaturation is also I'm giving you the none. So I can see some sort of colors by what we get, right? So I'll show you that how we get up the things, right? So it returns you a list of some RGB tuples, what you can see up here. Okay, so these are just an RGB tuples. The first one for the deep, the second one for the muted, the third one for the bright, fourth pastel, fifth one for the dark, and the sixth one for the color prime. So, like this, we have the RGB tuples, deep, muted, bright, and all of them, right? So if I just show you one of the like if I just show you the number of colors, what the n colors means. So like if I write SNS, if I say that current palette is going to be SNS dot color underscore of palette, and if I say the n colors to be 5, and I use this pal plot, just print this current palette. So I'll show you both the things, right? So what you can see, 1, 2, 3, 4, 5 colors. Got it? 5 colors have been printed up. Okay, so if I remove this thing, what do you think? What should come there? So the letters, all the things. So if I write this and I say that I want the pal plot. Now what is the pal plot, guys? What are these? What is this pal plot? So this is the another function which deals with all the color palettes. Okay, so this function plots the color palette basically. So these are the colors what you can see up here. So if you want to plot these things, you will have to use SNS dot pal plot, right? And that would work up there. You can see the colors. So if I say that I want some 20 colors, run this and you'll see all the 20 colors. Okay, so this is how it is being done. You can set the colors to something or whatever you want, like in several formats, whatever you want, however you want this to write up the things, you can write it there. Okay, so if I just tell you that I'm going to print the color palettes, okay, and uh, or else let's say if I'm saying that sns dot pal plot, and here if I write sns dot the color palette, let's say I'm writing oranges, so definitely I'm going to get the oranges, all the colors in the orange formats. Got it, my point. Color combinations I'm just printing, right? Let's say if I write uh, let's say for the greens, set a green for the greens, if you write for the purples, and several things are there, right guys, several things are there. If you write for blues, see, so we have various things and various patterns we could write this up, grays, let's say if I write for Vistia. So there are patterns and various functions here for plotting up your data. Okay, right? So there are various color platelets. Now we'll directly go up to the plottings and we'll try to understand like how we plot up our data. Like in the histograms and all, we'll be starting up with the plots now. So what is the first thing is a distribution plot. Now let me come here in my Seaborn. I need that it would be here. Now the things we have seen, that the subplots and all excess styles we have seen yesterday. Okay, with the C1 we'll see. Okay, now color palettes you have seen, right? How can you set, how can you write the color palettes? So define the color palette. This is used to just temporarily set the palettes, and if you want to set your own palettes, you can even write set palettes. We have seen this. So we'll be seeing up the plottings, and we'll start at plottings with the distribution plot, which is here, right? So it plots a univariate distribution, unvariate distribution. One particular row is being distributed with it, right? So if I write like, and I'm loading one data, let's say df2 or df1, and if I say sns dot data set of iris flower, okay, and this will see the head. So this is okay, this is df1. So this is the data set of iris flower where we have several things like petal length, petal width, and all. Okay, and then we are having species, setosa, versicolor, and all, right? So now our main goal is to distribute any one row, any one column. Okay, so this is defined by the distribution plot. The very beginning thing, the distribution plot defines this one. Okay, fine. So we'll write it as just SNS. If I just give the name to it. So what it does, what you can see here, plot unvariate distribution. Okay, or else if I write it as, so this plots an unvariate distribution. Now how to write SNS dot, let's say I'm using distribution, so this will be dist plot, okay, distribution plot. Now you have to define what is your data. My data is from the DF1. I only want to, let's say, plot the petal length. And then if I say the KDE, okay, I'm not going to write the KDE for now, alright, only let's say, and I say the colors to be green, or remove this thing. So what I can see, a data, cool, just a data with some petal lengths over there, okay. Now what is exactly the petal length? If you find, so these are all the values of the petal length, right? Starting from 1.4, ending in 5.1, and I can see up there, starting from like 1, okay, and ending it in the 5.4, okay, like 5.1, okay, right? Not 5.1. It's ending in somewhat around. I think uh, most probably if I use this sorting, I'll get it very clear. I think there are some changes in this. Yeah, so it's ending in 6.9. Okay, so that's what the difference. It's ending in 6.9. Okay, and that's how you see up your graphics. And this is just a KDE. I'll discussing what is KDE. That is a kernel density estimates. Okay, so this is a way just to estimate the probability density function of a continuous random variable, right? So if I say that SNS dot the plot, and I say I'm plotting the same thing, or let's say from here this time I'm going to plot something different. Let's say I'm plotting this sepal width, okay, and I'm saying the histogram. What I'm getting the histogram, right? So I'm getting a histogram with some lines with the curves over there. So if I write that I don't want the histogram, that is histogram should be false. And I say the color to be, let's say, pink. Got it? And we'll run this. Sepal width is not defined. Okay, it's in the DF1. So I'll see just a curve there. Okay? So you can use the style. The style, what I said in the previous time to you, right? What the styles to be used. Okay? Fine. So like if I write up here, it's not working. Okay. So like this is just a graph with some circumference and all what you have got there. So if we just write lp dot sort the values of this df1, and we want the sepal width and dot the values. So you'll see starting from 2 ending at 4.4, and you can see up there things ending at 4.4. Okay. Next, so that is about the KDE. Okay, next we have the joint plottings, right? Okay, so we are going to discuss about the first, we are going to discuss about the pair plots and all. Okay, before going to joint plots and all, we'll be discussing about the pair plots. So let's say if we discuss about the joint plot, so the definition would be, where is it, the joint plot? Yeah, so it plots bivariate distribution. Got it? Plots the bivariate distribution. So you worked here with univariate data, right? That is only one data when you are plotting only one data. Now remember, if you write this, what is it to be joint plot, okay? This plot bivariate distribution. So here that is just joint plot. And you write x. Let's say this is going to be the petal length. So here we'll be comparing up all those what we have taken in the previous one, the petal length and the sepal width. Okay, and let's say here I give my data, it's from DF1, and again I say that the color I'm going to write is going to be red. And let's run this. So you can see up your data. So joint plot means just giving you a bivariate plottings. Okay, so that you can work with your two plots. Okay, so that you can what do you say? So that you can work with some two-dimensional data, right? So x axis and y axis. Okay, so it creates a multi-panel figure for you that projects the bivariate relationship, and it creates a relationship between two variables on some separate axis. Alright, so we have got this, right? Next we will see about pair plot, right? What is pair plot? So pair plot, what it does, like it goes, right? It starts plotting with every respective column and every respective row, right? It takes the data, it just plot the graph with every row and the column being compared, right? Let's say if I write SNS dot pair plot and I say that iris is to be plotted. Sorry, DF1 is to be plotted. That's it. The only thing you write it like that. Now here we have parameters like data, palette, what is the palette you want to use, the kind of the plotting you want, the diagonals kind you want, and a lot of things are there, right? So we'll be doing it. We'll see it where. Just wait for some minutes. Okay, so we have got some plottings, right? But here, to identify that which of the point is of setosa, which of the point is of versicolor, and which of the point is of for the virginica, we cannot just justify, or we cannot just specify or find the difference. But we know that, like, if you see the data of iris, if you just explore the data there, you will find that this your data in the setosa is having a very separatable category, right? So this is setosa, this is setosa, this is setosa. All the things what you can see in separatable is the setosa. Okay. So what we'll do that. So we have seen all the histograms, right? So if you don't want to see the histograms, you want to like modify this. So if I say that SNS dot the pair plot, and I say I'm plotting DF1, where my hue semantic is like the labels, okay? So where I'll be differentiating the graphs, like giving it with the species. And I'll say the diagonal kind to be a KDE. KDE, you know, right? What we did in the previous one, KDE. You'll be getting, in place of the histograms, you'll be getting all the density plottings, okay? And I'll write that I want to see the graph as a scatter plotting. And I'll say that the palette we are going to use will be, what is that? Vistia. We'll wait a bit. It will be plotted and you can see the graph. Okay. So you can see and you can even differentiate now that this is light yellow is for the setosa, the orange is for the versicolor, and the deep orange you can see, or you can say the red, it's orange I think, for the virginica. And here we can see the KDEs in place of the histograms, and I could see now I can easily differentiate or separate up the things. So can we see the light yellows to be a separatable one? So can we say that setosa is being the way separatable category from all the three species? Got it my point? So that is being compared with sepal length with the petal width, sepal width with the petal length, and every four columns is being compared with every four rows. Or you can say the one column is being compared with the another column, and then you can see the graph between them. Got it my point? So four columns are there. Every individual will be compared to one. So 4 column 4 into 4, and you'll be getting a 16 graphs there in the pen plot, where every column is being compared to every individual column. Moving next. So now let's say I'm taking some weights. Okay, and let's take some height. One, two, three, four, five, six, 7, 8, 9, 10. Okay. So we have given some 10 weights and 10 heights. Now I'm going to plot a scatter plotting. Scatter plotting, you know, right? How we have seen up here the dots and all, we call it as scatter plots. Okay. So if I'm going to plot a scatter plotting, I'll say SNS dot scatter plot, and we'll say the x to be like, it takes two parameters. So we'll say the x to be the height, and we'll say y to be the weight, and the color we are going to use it orange. The white grid is being set. Let's just plot this. So you can see the plots there. Okay, if I set the grid, so you can see exactly the points lying somewhere and the data is coming. Like you can go on for this. You can find various things, like if you only plot the height of first 5 or weight of first 5, you can see a better visualization in the seaborn, I mean to say. Okay. Okay, then we are using different kind, that is the strip plot. What is strip plot? It is used when one of the variable is under category, right? Like a categorical value for when you are searching for a discrete value. Okay, that is we use the strip plots. We can see up here. Strip plot would be something here, I think. Strip, yeah. So it's a category of a scatter plot, and it is just like with one categorical variable. Okay, fine. Hmm. So it's like SNS dot strip plot. You can explore one by one when you start plotting up your data. You can easily explore up the things. So could not find species there. Already correct. That is because of the DF. It will be DF1. And I can see some Virginica, some versicolors, some species, right? So here I'm unable to just identify of the things very clearly. Why? Because what happens here, the uh, the points are just overlapped in between, right? So it just gives you a plotting. That's okay. That says that Virginica lies between 4 point and between the 7. Versicolor lies between 3 to 5, and so those are between 1 to 3, and all, right? But this is not a very good way of just printing up the things. So what I'll say that I'm going to use here a parameter that is called as jitter. So if I say the jitter to be true, what happens? You'll see the data still, right? You'll see the data, but there should be some difference when you write it as true. There should be some difference. And what that difference is, that overlapping will be quite less if you see with the previous one. Or if you say that if I write this here and if I write the jitter to be false even, then I will see just a line, and that will be a complete overlapping. Okay, that is just a complete overlapping in a very single way. Okay, so to avoid this overlapness, we have a different plotting that is called as swarm plot, right? So this avoid this overlapping in the scatter plots. If I write same thing, this only changing the one swarm plot, and rest the things to be the very same, and just plot this. So see, now you'll not get any overlapping in your things. See here the points are very clear. All the points are very clear. No overlapping would be there. Got it? But in case of this and this, we can find the overlap. Okay, moving next. Next, similar to this, we can use the box plots. Now, what are box plots? Where is this box plot? So it's not written up there. Okay. So what box plot does, guys? See, box plot distribute the data through their quartiles. Right? Quartiles means you can say that. What you can say for the box plottings? Quartiles you can define as the what else you can say? What you can outliers or quartiles. See, you can say the quartiles has to be the range or the last point, hmm, or even the what to say, then the ranges is that, but limits, yeah, limits you can say, okay. So you can say limits, right? Upper limit, the lower limits, and what, right? So these are just the limits. This provide you the graph within some limits. It gives you the limit that this range is starting from here and it goes to there, right? That is how. So the box plot works like if I write SNS dot a box plot of a same thing, okay. So let's say I'm using the box plot, and I'm saying that I want to plot this DF1. That's it. And I'm using my orient, horizontal orient, right? You can use vertical and all. So I'll be using it as horizontal. Okay. And for enlarging the size, right? Yesterday we did that PLT dot figure, and inside that fixed size is to be mentioned. So let's say if I'm writing the fixed size as 10 by 5, and obviously it's going to be a quite big one where we can see. So you have been find out with the limit that in the petal length, the value lies between something 0 point there and goes till 2 point something. In the petal length, it starts from 1 and goes till 6 point something. Okay. In the sepal bit, it starts with 2. Only one value is there. Okay. It starts with 2 and goes till something 4.5 around. Okay. And there in the sepal length, it starts from something 4.5 and goes till 7 point something. Okay. It gives you the limits of the quartiles, you can say. Okay. Next. So similar to this, we have even the violin plots, right? Similar to this, we even have the violin plots, which gives you the much data. So this is just a combination of this box plots plus the KDEs. Okay, the KDE, what we call the kernel density. So if I write that I'm plotting a violin plot, it will be obviously in the shape of a violin, right? But the combination of a box plot plus the KDEs. So let's say if I'm plotting the same thing with the data for the DF1, and here I did plot this one first. So you can see Virginica, versicolor, and the setosa. Okay, you got them. If you use the color, you can see other things. Or if you write red. Okay, so like Virginica starts from this 4, goes till the 7 plus, and the versicolor starts from this 2.5 or nearly approximately to 3 and goes to something. Okay, so that is the ranges and all accordingly you have got there. So you are plotting the species with compared of the petal length. So you can plot anything with the combination and you will get the same things with respectives. Okay. Now similar to this, now I'm going to leave another data that is being of the Titanic. So you can see, I think this I have displayed previously also. Alright, so not discuss about the columns and rows. Quickly just coming up to the next topic, that is going to be the bar plot. So bar plot, what it does, bar plot, it shows the relationship between a categorical and a continuous variable. So if I write a bar plot where I'll have to define my parameters, that is I'm using this X column, I'm going to plot the survival on the other side, and then I'm going to write that my hue semantic would be the class, the class, and let's say this is P class or whatever you take, third class, second class, or P class, whatever it is. So let it be on the basis of the classes. And now I'll be defining my data to be the DF2, and I'm going to take the colors to be green. So you can see the data, like one side is the 6 and in the other side on the y-axis we are having survived. So this much male survived, this much female survived, and according to that you can get other things, right? Now similar to thing that we can see just a bar plot, you can see, right? We can see up a bar plot. But what if we want to count, we want to see just a count plot of that. What do we can do there, right? So you can write SNS dot count plot, and let's say you want to see that how many sexes were there, how many male and females were there accordingly. So we want to see it from the data too, and we are going to use the color palette. Let's say I'm writing Vistia. So these are some of my favorite categories basically. I can use that. Or you can use cool, warm, or oranges. Find up the things accordingly. Okay. So there are various palettes, as I said to you. Okay. So even like what we plotted in the previous one, if you can see that this was a box plot of the 6 that survived according to their classes. So the third class is the deep class, right? So I can say from here that the third class male has survived very less as compared to this. The second class has survived quite much better than this third class, and the first class has been survived very much better than the third class. What about the females? The third class females have even survived much, right? The females have even survived much than the third class males. The second class females have also even survived much as compared to the males, and the first class has been also the same. Now I want to see the number of passengers in the classes. So how we can plot this? We'll be doing this model tomorrow. Okay? But to see the plottings, it will be easy if we just focus on the plotting today, and then we'll go for the modelings tomorrow, right? So let's say I'm focusing on the 6th column, right? And I say the hue semantic, right? The labelings I want it from the P class. Okay, that is, or let's say for the classes, the first, second, and the third class. Okay. Now, so my data is going to be DF2. And I'm saying that the palette I'm going to use will be this here. So I can get the data there. We can see that the third class were approximately around 150 females, and then it's around 70 or something 60 females in the second class. In the first class, it's quite 80. The males in the third class were about the 300 and what to say, it's 40 or 45 or 47 around. Okay, so like that, all the classes, the first class, second class, and the third class, that is being displayed here, right? Okay, now we can easily use this point plot event. So what does the point plot shows to you? So it shows the point estimates that confidence intervals between the rectangular bars. See, it basically gives you exactly the data of how this count plot works. Okay, but in case of this bars, it gives you the lines. Okay, now see, if I'm saying that we are going to plot the same thing, only the change will be done, that is here it will be a point plot, and the palette I'll be changing now. I'll be writing it as for the NP spectral. And the data remain the same, the survived and all, let's remain the same, unsupported for the strings. Okay. So it would be P class, and still unsupported for the strings and the integers. Is that string? So okay, let's see the survived then. Alright, we are taking hue semantic, right? Okay, fine. So it can be the P class. They actually have to write one more parameter, that is phi. So you want to compare between the two things. So let's say you want to see the survived. So it would be exactly like the number of males. So what were the number of males survived? If you can see up the bar plot, right? The same thing. Number of females survived in the third class. The male survived was less than the 0.2. If you can see here, the less than the 0.2 even, right? less than 0.2, and the number of females survived in the third class were greater than the 0.4 nearest to the 0.6. So greater than the 0.4 nearest to the 0.6. Okay. And the same things, right? I don't need to explain this, right? Because this is very easy as compared to the previous one. This is the only formatting has been changed up, right? Everything remains the same. Okay, fine. Now we are going to see some facet grid. Okay, what facet grid does. So what facet grid does exactly is, like, I think here it should be mentioned up. It is facet grid, I think, can be, yeah. So facet grid gives you a subplot gridding for conditional relationships. Like it's kind of an excess grids. The above, like you say for what you can say that it provides you all the columns plottings, or let's say all the individual classes plottings of a data. How? Let's see. Like if I load a data set, or let's say for the Titanic even, if I'm going with the Titanic. So I'll be using some factor plots when I focus on this facet grid. Or let's say if I write the G is equals to some categorical values it gives, right? So if I write SNS dot the facet grid, so let's say here if I write the data to be DF2 and I want to write the column to be survived and the row to be the sex, and I say G equals G dot map, and the, let's say, plotting the histograms, and let's plot the histogram of the age of the passengers. We'll see a histogram here, and that's it. Okay, like that. The number of male or the female survived, not survived, and according to that. So you have written the rows to be the sex and the columns to be the survived. So you see the number of males survived 0, number of males survived 1, the number of females survived 0, number of females survived 1, and that is how it is being represented. So you can change the colors and all, like here if you want to change the colors, you can even change, let's say you want some pink color, right? You can take any color, right? Orange, red, and anything. So let's take green. Moving next. So the last part we are going to focus for the plottings is the matrix plot. Okay, matrix plot, or we can say the heat map, right? So before that, the last part of the two things is this LM plot and the factor plot. Okay, so LM plot is basically used for the linear regression plottings and all what we do. Okay, so let's say if I load a data set, or if I am going to plot any data, right, SNS dot, let's say I'm using the regression plot. So that is being, I think that is being defined here also. So this plots an regression model that fits around the facet grid, right? So LM plot also might be there. Where is that? LM plot. See, this is regression plotting, okay, and there was an LM plot. So regression plotting plots the data of a linear regression model fittings. Okay. So if I write that X is going to be the, let's say, the total bill. Remember that DF data, the first data what you have loaded, and let's say this tip and the data from the DF and the color to be green, red. So you can see up your plottings. Okay, a regression line that fits between all the So this is the line that is the regression line. You can say that fits along all the points, best fitting line, right? So if you apply semantic here, see the semantics here. This is what we using the LM plot, but the same things, right? Not being changing the data. So I'm going to plot the same things, right? For the total bill, what is being plotted up here. So X is going to be the total bill, and my Y is going to be the tip. The data is from the DF, and the hue semantic now I'm going to use will be the 6, so that it could give a better plotting. So you can see the males and the females as well up here, right? Compared to things. And the last is the heat map. So if I write SNS dot a heat map of the correlation of this whole data set of this tip, and I use the C map at the color map with the VSTR. So I can see a color map of all those things. Okay. So if I just give you the same thing, okay, got something shapes. All right. So if I use something next, like maybe spectral. No, this is not good. Let's take for the oranges. That will be working well. So these are all the colors and plottings what we do in the Seaborn. So I have shown you all the different kind of plottings we can do in the Seaborn with our datas, and we'll be focusing up next with. So tomorrow we'll be dealing up with all those data sets and we'll make the models. Okay.